everyone. You've been working away in your probability unit, and today you're going to talk about something called expectations. And expectations means just using a bit of math to figure out what might most likely happen in an experiment. Okay, so I'll give you a couple of examples first. So let's talk about flipping a coin. That's one that we can relate to pretty well. I think all of us have played some kind of flip a coin game or experiment. So we know that on a coin there's heads and tails. So this says, what would the expectation be of flipping a coin and landing on heads? All right, so if we think about the coin, we know that there's two sides in total on the coin. So I'm going to use a fraction to show the probability of landing on heads right now. So there is two sides on the coin, so two different outcomes that could happen, heads or tails, but tails is only one of them. So landing on heads would be given a probability of 1/2 or 1/2. You have half of a chance of landing on heads. Okay, that's equally likely to tails. Now, rolling a die and landing on 4. Okay, so if you think about the total amount of outcomes when you roll a die, you know that there's 6 numbers on a die. That means there's 6 different outcomes that could happen when you roll that die. And if you're looking to land on the number 4, well, that number 4 is only on the die one time. So that means that the probability of landing on a 4 is 1/6 or 1 out of 6. So this is saying if you flip that coin twice, 2 times, you would probably land on heads once. Okay, if you roll that die 6 times, you would probably land on 4 once. That's how you would read that. Okay, so then from there, we can think, now what if we flip that coin or roll that die more than 1 time? So what if we flip that coin 10 times? Then how many times would we expect to land on heads? Now, probably for most of you who are thinking on it, will right away say 5. Why? Because 5 is half of 10, and we're expecting to land on heads half the time, and you kind of knew that math already. Now, if you were going to show that and show your work, we know that the probability of landing on heads is 1/2, and we are now going to be, instead of spinning that, flipping that coin twice, we're going to flip it 10 times. So that means the total changes from 2 to 10. And how do we change a fraction? Well, we'll multiply the top and bottom by the same number. So how do I get that 2 to turn into 10? Well, I'll multiply it by 5, which means I multiplied the top by 5. So this should look familiar from when we did our fractions unit and making equivalent fractions. So that means that if I were to do this experiment 10 times, flip that coin 10 times, I would expect to land on heads 5 of those times. Now, will that definitely happen? Will you definitely land on it 5 times? Maybe not, because flipping a coin is a game of chance. And so anything could happen in these games, but this is just giving us an idea of what will probably happen or what is a good chance of happening. Okay, so it would be around 5 times we'd land on heads. And now, if we're thinking about rolling the die and landing on 4, so say we do this experiment and we are going to do it 18 times. Okay, so we know if we did it 6 times, we would land on 4 1 time. So I'm going to make an equivalent fraction, and I'm going to now change those 6 rolls into 18 rolls. So that means I'm going to multiply by 3. That's how 6 times 3 is 18, which means top is by 3. And that means that if I were to do this experiment 18 times, roll that die 18 times, I would probably land on 4 about 3 out of those 18 times. Okay, so you can predict about how many times you can land on a certain outcome depending on what you know the probability is. All right, so moving on to the spinner question here. I'll just do one more example with you before you head into your book work. So let's look at this spinner. This spinner has 1, 2, 3, 4 parts. All right. And I'm going to put the probability of landing on each color up here. So I can see that, so right away actually I'm going to go ahead and put 4 there because the total number of parts on that spinner is 4. 3 out of 4 are blue. and 1 out of 4 is red. So if I were to play this game 4 times, I would expect I'll probably land on blue 3 times and probably land on red once. That may or may not happen, but this is our best guess based on numbers, all right? Now, what if we were going to play this game 8 times instead of 4 times? Then how many? So again, what we're going to do is, let's say we're looking to land, we'll pick blue here for these. So if I spin it 8 times, how many times will I land on blue? Well, again, I'm going to make myself an equivalent fraction then. So I know 3 out of the 4 parts are blue. Okay, and if I want to play, instead of 4 times, I want to play 8 times, I'll just change my denominator. So then I'd be multiplying both top and bottom by 2. That means 6 out of 8 times, I would probably land on blue. All right, so if I were to spin it 8 times, I'll probably land on blue 6 of those times. Okay, let's try for 16 now. If I was going to do this experiment 16 times, then I'd multiply top and bottom by 4, because that's how I'd get 16 there. And if I play 16 times, I would probably land on blue 12 of those times. All right, 24 times. If I played 24 times, I'm going to multiply by 6. So hopefully we remember all our multiplication facts here. And that means that I'll probably land on blue 18 out of those 24 times. And then you can figure out the same thing for the red as well, using the same method. So you can just use equivalent fractions to find your probability if you play the experiment or play the game or do the experiment many times. All right, so this is kind of the strategy that you're going to use to get your answers today. So have fun with expectations, and we'll talk to you soon.